elementary and physiological optics. Light, this is general chapter, so we'll move first. Light is a form of energy whose interaction with the retina gives sensation of sight. It lies between ultraviolet and infrared portions. From 400 nanometer at violet end of spectrum to 700 nanometer at red end. Nature of light, various theories are given. At present, it is universally accepted that, like matter, light also has dual nature. That is, it possesses characteristics of both wave and particle. Properties of light: it provides an electronic magnet. Speed of light in free space is 3 into 10 power 8 millisecond, meter per second. Transverse in nature, monochromatic, non-deflected. 300 to 723, 300 in violet end, 723 in red end. Visible light and eye, media of eye are uniformly permeable to visible rays between 600 nanometer and 390 nanometer. Cornea absorbs rays shorter than 295 nanometer, therefore rays between 600 nanometer and 295 nanometer only reach the eyes. It's important point. So lens absorbs rays shorter than 350 nanometer, therefore rays between 600 nanometer and 350 nanometer can reach the retina in phakic eyes. Those between 600 and 295 in aphakic eyes. Eye is more sensitive to yellow-green light, and sensitivity decrease on both sides of wavelength, so it is minimum for violet and red light. Most sensitive to green light. Physical optics. Wave optics. Wavelength is a light wave is defined as distance between two symmetrical parts of wave motion. Amplitude, maximum displacement of imagined particle on one wave from baseline phase. Interference, diffraction, polarization. Quantum optics. Quantum optics treats light as a particle called photon. Phenomenon based on quantum optics are transmission, scattering, laser, fluorescence. Geometrical optics, behavior of light rays is determined by ray optics. The ray optics therefore use geometry of straight lines to account for macroscopic phenomena like rectilinear propagation, reflection, refraction. Reflection of light, loss of reflection. The incident ray, reflected ray, and normal at the point of incident all lie in the same plane. Angle of incident is equal to angle of reflection. Mirrors, mirrors, types of mirror, plane mirror and spherical mirror. Plane mirror, it is of same the image formed by a plane mirror, it is of the same size of the object. Light lies at the same distance behind the mirror as the object in front. It is laterally inverted, virtually in nature. Spherical mirror, concave mirror, convex mirror, whose reflecting surface is towards the center of the sphere. Convex mirror, whose reflecting surface is away from the center of the sphere. Cardinal data of spherical mirror: curvature, radius, center of curvature, radius of curvature. Spherical mirror, center and radius respectively. Normal is the spherical mirror at any point is the line joining point to center of curvature. Pole of mirror, center of reflecting surface. Principal axis is the straight line joining pole. Principal focus of mirrors is point of principal axis of mirror at which ray incident on mirror in a direction parallel to principal axis actually meet. Focal length of mirror is distance of principal focus from pole of spherical mirror. Images formed by plane mirror. Image from the concave mirror is given. Refraction of light. Refraction of light. Loss of refraction. The incident and reflected light are on the opposite sides of the normal and all are in same plane. Ratio of sine of angle of incident to sine of angle of refraction is constant for part of media in contact. The constant is denoted by letter mu and is called refractive index of the medium. So total internal refraction, when a ray of light traveling from a let's see the Snell's law, sin r equal to mu square. It is Snell's law. So let's move to the total internal refraction. When a ray of light traveling from optically denser medium to an optically rarer medium is incident at an angle greater than critical angle of the pair of media in contact, the ray is totally reflected back in denser medium. Critical angle refers to angle of incidence in denser medium, responding to which angle of refraction in the rare medium is 90 degree. Application: the principle of total internal refraction is utilized in many optical equipments. Fiber optic lights, applanation tonometry, gonioscope, prism. Apical angle axis of prism refers to line bisecting the optical. Power of prism is measured in prism diopters. Image formed by prism is virtually erect, displaced towards apex. Diagnostic include objective measurement of angle of deviation, measurement of fusional reserve, diagnosis of microtopia. Prisms are also used in many ophthalmic equipments such as gonioscope, keratometer, applanation tonometry. Therapeutic use of prisms are to relieve diplopia, for exercise, to develop functional reserve. Biconvex lens, plano convex lens, and concave convex lens. This is a cardinal data of lens, similar to a mirror. Types of lenses: spherical lens, convex lens, or plus lens is a converging lens. It may be of biconvex, plano convex, or concave convex. Identification of convex: the convex lens is thick in center and thin at periphery. When a convex lens is moved, the object seen through it moves in the opposite direction to the lens. Use of convex lens: it is used for correction of hypermetropy, aphakia, presbyopia, in optic illumination examination, in direct ophthalmology as a magnifying lens, and in many other equipments. Image formation by a convex lens is given. So concave lens, it is of three types: biconcave, plano concave, and convexo concave meniscus. Plano concave with biconcave, plano concave, and convexo concave. Use of concave lens to correction of myopia, and as ruby lens for fundus examination. Cylindrical lens. Cylindrical lens acts only in one axis, that is, power is incorporated in one axis, the other axis having zero power. The cylindrical lens may be convex or concave. Convex cylindrical lens is a segment of cylinder of glass cut parallel to its axis. Refers to a lens cast in a convex cylindrical mold. Concave cylindrical lens, axis of cylindrical lens is parallel to that of cylinder of which it is a segment. Power in a cylindrical lens is present only in direction at right angle to axis. Identification of cylindrical lens. This is cylindrical lens, convex and concave. Opposite to the lens only in one direction, it is identification. Use of cylindrical lens prescribed in astigmatism, as a cross cylinder used to check refraction subjectively. Maddox rod consists of power convex lens. Typical types of cylindrical lenses: simple compound cylindrical lens, mixed cylindrical lens. Physiology of optics. Images formed by cylindrical lens. It's best understood in the study of terms conoid. Eye as an optic instrument. Eyelids are shutters of camera. Cornea and crystal lens are focusing. In fact, cornea, crystal lens along with humor and vitreous constitute the homocentric system. Iris acts as a diaphragm which regulates the size of aperture and therefore the amount of light entering the choroid. Choroid helps in forming darkened interior of the camera. Retina acts as a light sensitive plate or film. Schematic eye cardinal points: 2 principal foci f1 f2 which lie 15.7 mm in front, 2 principal point p1 p2, 2 nodal point n1 n2, 2 diopter power of total diopter power of the schematic eye is 58.64 diopter. Reduced eye. Eye has been simplified further: principal point, nodal point, anterior focal point, etc. Functioning of eye as an optical system. Eye, inward image, optic nerve, brain, picture seen by the brain. Axis and visual angles. Axis, optic axis is a line passing through center of the cornea, center of lens and retina. Visual axis is the line joining fixation point, nodal point, fovea. Fixation axis is the line joining fixation point and center of rotation. Visual angles: angle alpha, angle gamma, angle kappa. Optical aberration of normal eye. Normal mechanism to decrease aberration: cutting of peripheral eye rays by iris, high refractive index of core, low sensitivity of peripheral retina, Stiles-Crawford effect, that is more sensitivity of retina to perpendicular light rays. Physiology of optic defects in a normal eye include diffraction of light, spherical aberrations, etc. Diffraction of light brought to focus does not come to a point but give rise to blurred disk of light surrounded by several darkened light bands. Chromation aberrations, color aberrations, etc. are also seen. Decentering, oblique aberration, coma, etc. also seen. Thank you.